be talking about strategies and standard algorithms and how each grade level solves them. We'll be looking at second, third, and fourth grade today. The problem we'll be working with today is 307 minus 128, and I'm going to take a second just to write this or type this over here so we don't forget it. Okay, and then I'm going to put it over here in this small little corner just so it's out of our way. So, elementary students can solve subtraction problems in many different ways throughout each grade level. As I said earlier today, we're going to just go through the strategies that some second, third, and fourth graders may potentially use. But first, we'll start with second grade. Second grade students will use base 10 blocks to decompose the numbers to make it easier for them to solve. So we have 307 minus 128. So first, a student would start out with 3 flats. Oh, let me break this apart a little bit. And then that 3 flats represent 300. So they will not lay out any rods of 10 because there's a 0 in the tens place. And then that means there's no 10s to represent. And then the student will then move on to place 7 unit blocks to represent the 7 ones in the number 307. Three, 4, 5, 6, and 7. Okay, so now that the student has represented a large number of 307 to base 10 blocks, the student can now start decomposing the blocks with a smaller number of 128. To do this, the student will first look at the ones place, right here, and realize that they only have 7 unit blocks. So they can't take 8 away from the 7 because there's only 7 one little blocks. They will then decompose one of the flats into 10 rods. So we'll take this third flat and get rid of that, and we'll make 10 rods out of that. So 1, 2, 3, 4, 5, 6, oh no, 7, 8, 9, and 10. So 10 of these represents 100, or 1 flat. The student will then break one of the 10 rods into 10 unit blocks. So we'll take one of these and break this up into 10 unit blocks. So 1, 2, well, I shouldn't say break up, we should regroup them. There's 2, 3, 4, 5, 6, 7, 8, 9, and 10. And just so we can see it easier, I'm going to put them in a stack, like in a row, just so we know that that is the same as 10 and 10 rods, and we regroup them. So let me just put these up here. Okay, so you have your 10 ones here, and then you have 7 more over here. So in all, you should have 17 with these 10 ones and these 7. You should have 17 unit blocks together, which now gives you enough for taking away 8. So you'll be taking away 8 from the 17 since we decomposed a 10, we have to make the 7 a 17. So in a standard algorithm, you would cross out the 7 and make it a 17. And then we would cross out the 0 and make that a 9. But we'll get into that a little bit later. So we will take away, so now we're going to take away 8 from 17. So we would get rid of 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then we do want to delete those. Okay, so we got rid of the 8. So that gives us, let's see how many ones that gives us. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so just for the sake of not being confused, I'm going to go ahead and I'm just kind of write down what we've done. So we'll take 307. Oh, let me get a pen that works. Okay, 307 minus 128. Okay, so what we've done is we have taken the 10, a 10 rod from a flat. So we broke this up. We broke the 3 flats, or one of the flats, into 1, and then we have 2 flats left right here. So we'll make this 3 a 2, since we have 2 flats left. And then we made 110, but we broke that up and gave it to the 1. We broke the flats up, or decomposed them, into 10 rods, which made that a 10, but now it's a 9 because we decomposed the rod and gave 1 away to the 17. So, or to the 7. So we'll make this a 17. So we did 17 minus 8, and we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we do have 9. Let me just change the color just for the sake of not being confusing. So 9 is what we would put in our ones place. So moving to the tens place, you now have 9 minus 2. So the student would then, they have 9 rods right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in order to get 2 away, you would have to, represent 9 minus 2, you would have to take 2 rods away because they are in the 10 spot. So let me get rid of this. You would click on 2 of these. And then delete those out of the way, or take those away. Yes, okay. So then you have 1, 2, 3, 4, 5, 6, 7 left. So you have 7 tens rods. So that is where, and 9 minus 2 is 7. So this is where we would write 7. And then 2 minus 1, so then we'll move down to, since we're done with the tens, we will move to the hundreds place, which is the 2 minus 1. And these flats up here represent the hundreds. So we have 100 and 200. And so we have 2, but we need to take away 1. So we're going to go up here and click on this. And we are going to remove it. And now that leaves us with only 1 flat. And so now we will go back down to our problem and write 1. And so 1, and then so that leaves you with your total answer of 179. And this is the second grade strategy that they would use for this. Now moving on to the third grade strategy. Let's just go to this third one. I believe that they would use a open number line just because addition is kind of simpler than, or it's easier for students to understand than subtraction is. So I feel like they would add the numbers and then count the difference in between the spaces to get that difference. So let me go ahead and write, it's the same problem we're going to do. 307 minus 128. Oh. And I'm going to just kind of put this up top this time so we can see it a little bit better. So the student will first begin by drawing a number line. So I've already drawn the number line just to be prepared a little bit better. The student will start at 128 because that is the smallest number on the number line. And when you're reading a number line, it goes from left to right, just as you're reading a book, and it increases as you go further right. So we're going to go over here, and just for neatness, I'm just going to type it. So 128, that way it can be a little bit better read. 128 on the number line. And then we are going to go ahead and place the largest number of 307, which is what we are working with at the end. So 307, kind of move that over here. All right. And then in between, the student would put the numbers. So in this case, I feel like it's typically easier. Most students typically use like whole numbers and bases of 10. So in this case, I have thought about how a student would do it with 100. So let me go over here. Okay, so they would start with 100. So it would be, we'll put 228 right about there. And type, okay, so 228. And let me just move that. Okay, so the student would then go with from 128 to 228. They know that would be 100 jumps. So they're going to write 100. They would write 100 up here. So the difference between 307 and 228, there's not really another 100 that they could do, but another whole number that they could do based off of that would be 298. So they would then jump their way to 298. So let me represent that real quick. 298. And we'll just put that kind of close to the 307. I'll put it right about there maybe. And then let me do a little line to show that that is on the number line. Okay, and then so from 228 to 298, they would jump from 228 to 298. So let me change my color to green. And they would realize that that is another 70 jumps between 228 and 298. So that's 70 jumps. So what they're going to do here is they're going to add 100 and then plus 70. So they'll put a plus sign there to remind themselves that they need to add at the very end. And then 298 to 307, they would just jump more until they would just continue jumping until they got to 307. So we'll just jump. So okay, and then they would count the jumps that they did. So 1, 2, 3, 4, 5, 6, 7, 8, and you kind of hard to tell, but that's the jump. 8 and then 9. So then they would write a 9 here. And then by the end of it all, they would count to know what their final answer is, and the difference between the numbers of 307 and 128 would be they would add 100 plus 70 plus 9. And when you add 100 plus 70, we'll just kind of write it over here real quick. 100 plus 70 plus 9 is going to give you 0 and 0 is 0, and then 9. 0 plus 9 is 9. And then 0 plus 7 is 7. And then you bring the 1 down because there's nothing there. And you got 179. So just like in our first problem with second grade, we got the answer of 179. And just like in this problem with third grade, we got the answer of 179. So that is definitely a good way to think about your strategy, or a different strategy to think about for third grade without using base 10 blocks. Now fourth grade, this one, this is where they start learning actual standard algorithms and they start putting it into practice. For this strategy, I feel like a student could use anything really from just a regular standard algorithm to expanded form to anything. But I chose to do a place value chart just because I felt like it would be easier. So let me just go ahead and make the chart real quick. Let's see. Well, let me write the number out first. It's going to be the same problem. 3, 0, 7. And then down here you have 1, 2, 8. Okay. And then you want to draw your equal line. So just to break it up a little bit and you can see what I'm going to do, we'll just break it up a little. Okay, and just so we know what is what, let me put the names above them. So there's the hundreds. Tens, and lastly the ones. Okay. So now that we have our problem and we have split the numbers into the place value chart into their rightful places, you should always start with a hundreds place in case we need to take away from the 10. I'm sorry, we should always start with the ones place, not the hundreds. We should always start with the ones place in case you need to take away from the tens and then the hundreds. So as seen in the second grade video, you can't really tell, you can't really take away 8 from 7 because you only have those 7 little unit blocks. But here, I think it's more, maybe a little bit easier for a fourth grader to understand because they don't have to count those little blocks. But, okay, so here they have 7 minus 1. So they know that here it's easier for the fourth grader to see that 7 and 8 are in the ones place, so I guess that would represent 8 little blocks. So they know that they cannot take 8 from 7 because they don't have enough. So they would have to then cross out the 7. But they jump to the 10 spot and they realize they don't have any 10s to borrow. So then they can't regroup. So then they realize that they're going to have to jump to the hundreds place and take one of those hundreds and regroup them. So that's where they go and they cross out the 3 and they make that a 2 because now they only have 2 hundreds because they're given one to the tens place. But now that that's a 10 right here from that, the 7 still needs a 10 too, so they can regroup. So the student will then cross that out and make this a 9. And then since that is crossed out, they gave their 1 to the 7, making that it's a 10, so that makes it a 17. So now that all that, the messy work, I would say, is kind of done, they can now just subtract all the way out. So 17 minus 8 is going to be 9. 9 minus 2 is 7. And then 2 minus 1 is 1. So here they have their total answer. Here they have their total answer of 179. I think that's a very reasonable way for students to learn and know that without using a hands-on manipulative or a base 10 block, that they can like use that chart and still visualize the ones, the tens, and the hundreds. But yeah, so we've gone through all of the strategies. We'll just go back and kind of review. We did the second grade with the base 10 blocks, and I think they are more hands-on and have to visualize it and like really physically touch it to understand it. Whereas when you progress to third grade, they're starting to get into that. They still have a visual of a number line, but they're starting to really understand different strategies and ways to figure it out. They like in this case, the student would choose to do addition instead of subtraction because maybe it's easier for him or her to do addition than it is to subtract. But they still got the same answer. And then progressing in the fourth grade, this just honestly it starts becoming more mental math than hands-on and manipulatives. But they also use like hundreds charts and tens charts and ones charts or place value charts to like keep track of what they're doing and why they need to regroup and where they need to regroup from. So yeah. So each student is upon each grade level solves the same problem differently. But just because the standard algorithm is a fourth grade standard, it does not mean that a second grader has not been introduced to it before. They just solve it in different ways.